Okay, we are headed for the second part of what you need for today, having to do with extending patterns. This is also going to be from Jump Math, so this will be what you need. We're going to go to the document camera, check this out, and we'll look at using our tables of values again. So this time what I've done is I've set up an example for you of extending patterns when you're given a physical pattern or sometimes concrete materials. Things like blocks, etc. So here I've drawn our first picture. So this is figure 1. And figure 1 is a table. It's got 4 chairs around it. And then I've started the pattern off, figure 2. We add a table and we bump it out so that we can add more chairs. In our first one, we have 1 table in figure 1. So here the figure number matches the number of tables. That doesn't always happen, but sometimes, like today, it will. And there are 4 chairs when we have 1 table. As we move along, there are 2 tables in our second figure, and there's not 8 chairs. It doesn't double. If we look, there's 1, 2, 3, 4, 5, 6 tables. 6 chairs when there are 2 tables. Figure 3, we could make a prediction. If we draw in our tables for figure 3, there are going to be 3 tables, and 1, 2, 3, 4, 5, 6. I'm drawing it that way on purpose. It gets bumped out. 7, 8 chairs. So we can use this type of thinking, and remember, our figure number is kind of like our x, and our number of chairs is kind of like our y for today. When we do more algebra, we'll write it like that. And what we're doing this time is trying to determine what a rule is, and also make some predictions for the different pieces that we're going to add to this. So this time it looks like the pattern going down here is +2, and since these are in order from 1 to 4 in consecutive order from least to greatest, we can trust this pattern on the side, and we can actually cheat a little bit to figure this out. So what are we doing for the figure number to get to the number of chairs? At first it looks like we add 3, but that doesn't work for here. 1 plus 3 is 4, but 2 plus 3 is not 6. So we extend this pattern here to help us be able to identify some of the physical things working with actual concrete materials. And we would do that, and we would need to find the rule in order to figure out what would happen if we continued this pattern. Let's say it was for a big banquet and you were inviting more and more people. As more invitations came in, you had to add more tables, and you were creating this giant table to fit in a gym for a grad banquet or something like that. And let's say we ended up getting all the way up to 20 tables. We want to be able to find some way to figure out how many chairs there are without having to draw all this out. The way we do that is figure out what the rule is, and in algebra terms, that's what we call the expression. And the expression is whatever we do to our x value to get our y, or in this case, how can we tell how many chairs there are just by knowing the number of tables? So in this case, if we take a look at it, it seems like if we take the number of tables and multiply it by 2 and then add on 2, it works every time. And there's a trick for this which I'll show you later on, but this time the rule or the expression is 2 times the number of tables plus 2 is going to help you figure out how many chairs there are. That's a description in words. We could take that further, and instead of just words, we can write that a little bit more algebraically, and we'll get to that this year. 2 times our x, which is standing for our number of tables, plus 2 is equal to y, or in this case, the number of chairs. So if x is 20, I want to take my number of tables, which is 20, multiply it by 2, and add 2, and that'll work out to the number of chairs. Stop for a second and see if you can do that on your own. Can you figure out what that is? Well, 2 times 20 is 40, plus 2 is 42. Figuring out the rule really helps when you have to extend it past a reasonable point where it's no longer practical to continue a giant table or write out all these diagrams here. So this goes along with jump page 29, 30, and 31. Hopefully you'll be able to use these 2 lessons to help you out with this. And like always, if you have problems with it, please shoot me an email or give me a quick message on Google Classroom.